Good morning, afternoon, evening, whatever it is for you. Good day, I guess I should say. We're talking about 7.5, which is going to be a very wonderful thing of exponential functions. This will be the start of the second part of chapter 9 for us. I have a few problems here that I'm going to ask you guys just to quickly do, and I'll give you the answers again tomorrow when you show up to check over this stuff. So just to get us back to thinking with quadratic formulas. So with this lesson 7.5, we're talking about exponential functions. Now, exponential functions are written in a very specific form. That very specific form is right here, where it's a times b to the x, where a cannot equal 0, and b is going to be a number that is greater than 0, but also not equal to 1. So examples of this form would be these three here, where I have 3 times 2 to the x power, y is equal to a 5 to the x power, and y is equal to a 1/3 to the x power. Again, all of the b's were greater than 0, and they were not equal to a 1. In this case right here, a is equal to 1 because that's the number that's in front of the 5. So you can imagine it kind of like a coefficient. So we're multiplied with little parentheses there of times 1 would be what you are hopefully recognizing, because b is going to be always the number that's to the power of x. Alright, some really important things here is when we're graphing in our first example, we have y is equal to 4 to the x power. Now if we're trying to find the y-intercept, the very first thing that we need to recall is that when you're trying to find the y-intercept, that's where x is equal to 0. So we might as well make a table of our x values and then what our y values are to help us graph. Because remember, if we don't know how to have a specific pattern that we're going to use, we just make a table to graph things. So you're going to use your trusty calculators to help you figure things out. So let's start with our normal set of numbers, -2, -1, 0, 1, 2, and let's see if we can get this graph to look for us the way it's supposed to. So when I plug in a -2 for x, it's going to say y is equal to 4 to the -2. So in your calculators, you're just going to say 4, little caret key, -2, and you get the answer of 1/16. Okay, 1/16, so we go to the left 2, 1/16 is just barely above 0, and it's to the exact same thing, 4 to the -1, which is 1/4, so we left 1, up 1/4, just a little bit higher up, and then we're going to plug in a 0. Now, this is something that we should recognize right away. When we plug a 0 in for x, because x is always the exponent, what we talked about earlier in the year was that if you have any number to the 0 power, the answer is 1. So we're consistently going to have a y-intercept of 1. So we so far can answer the question that y-intercept is equal to 1. So we'll know what that is on a regular basis. And then we can continue on with our next ones. Plugging in a 1, 4 to the first power is a 4, so to the right 1, up 4, 1, 2, 3, 4. Things are going up rather quickly. And then 2 is our next number for our x, will be 4 to the second power, which is a 16. And that's going to be way up here, so we're just going to, I guess, leave it the way it is, because I can't draw that without skip counting. Now what I want you guys to notice with our chart here is that the exponential functions are going up very quickly, but they also are never going to be equal to 0. So we're never going to touch this x-axis here. So we're getting closer and closer to the x-axis, but we never are going to touch it. That's called an asymptote, where the line never gets to touch it. It's approaching the line, but it never actually gets there. So our job is to draw a quick sketch of this. It's going upward, and you can see very much that it's a graph that looks like that. Our job is to now state that we have a y-intercept of 1. Our domain, remember domain is x values, left and right. Our x values are going to be all real numbers, because they're going all the way to the left, all the way to the right, because this is going to continue to go to the right as we go further up. And then our range And this is what is going to be different for us. Our range is the y values, and that's going to be all numbers that are greater than 0, because it's never going to get to this 0 spot. So it's all numbers that are greater than 0. Now the last part of this question asks us to find y is equal to 4 to the 1.5 power. So just looking at the graph, if we go to the right 1.5, we'll be up here at like maybe an 8-ish. So we would say this is equal to about 8. Now again, we're going to use the about symbols, so let's make this a little squiggly equal sign. It's about 8. Now we would want to check with our calculator just to double check. 4 to the 1.5. Oh, it was exactly 8. So I guess we did a pretty good job of making an educated guess there based off of the graph. Now you're going to try the one on your own, look at the graph very carefully, and make your best guess as you guys can by using your brain. Alright, so we're going to try another one very similar to the last one. Our job is to find a 1/4. Now again, we're going to make a quick table to make these things a little bit easier. Here's our x, here's our y. If we plug in negative numbers, remember that we always know that x is 0, y is 1, so we're going to have a point right here for sure. But let's plug in these numbers. So I'm going to use 0.25 to the negative power to make this a little bit easier for me. And this is a 16 in my calculator. So I went to the left 2 and up 16. So that's going to be way up here, okay? Now we're going to do the exact same thing. We have a 0.25 to the negative 1 power, which is a 4. So left 1, up 1, 2, 3, 4. And then we're going to have a 1 power. So to the right, we're going to have a point or a 1/4, and then a to the second power, 0.25 to the second power is a 0.06. Woof! So it's really, really close to the 0. So this is pretty much the opposite of our previous graph. And again, it never touches the 0 of our x-axis. So it's getting closer and closer and closer. So this is going to be the 1/4 and 1/16 for our 1 and for our 2. Now again, our job is to approximate the value of a negative 1.5. I would guess that it's going to be an 8 again. And that's just based off of going over here and looking up. It's about at an 8. And I'm going to check with a trusty calculator, 0.25 raised to the negative 1.5. And it's 8 again. So my y-intercept was 1. My domain is all real numbers. And my range is, again, where the values are greater than 0. And then to answer the question of here, to approximate, well, 1/4 to the negative 1.5 power is about 8. So again, we want to use the squiggly line. You can check with your calculator to see how close you are. Now, that's what this entire section is all about, folks. So here's another problem for you to try on your own, and we'll check with you when you get back. And then the assignment, this is what we're doing for 7-5, folks. This is Burmanation signing off. Enjoy the time.